Okay, so we're going to still be factoring trinomials, but these, there's going to be, some of these, there's going to be a number in front of the x squared, which is going to make it more challenging to factor it if we're trying to use the factor pairs and do the multiplication to get this and addition to get this. So we're going to do a method that's called slide, divide, and then bottoms up. All right, so that's what's on your little half sheet. So the first thing we're going to do, if possible, is factor out the greatest common factor. That's nothing new. So if we're looking at number 13, is there a common factor with those numbers? 2, 15, and 18? There's not one. So when it's the situation where there's not a common factor, but there's still a number in front of x squared, we're going to kind of just trick the problem into being a different problem to make it easier for us to factor. So the first part is to slide. And so step 2, if there's still a number in front of x squared, what we're going to do is temporarily transfer this number to the last term by multiplying by it. And that's called the slide part. So what we'll do, I'm going to go over to the side, and I'm going to multiply 2 by the 18. And when I do that, it's going to be 36. So then, since it slid over with the 18, it's not there anymore. So I just have x squared, and then the 15x stays the same, and 18 turns into 36. All right. And then if you're looking at your little half sheet, now it says step 3, just to factor like normal. So we're going to factor it just like we have been. We're not going to be done. We'll have 3 more steps after that. So we're going to factor like normal, where we are going to multiply to get 36, and we're going to add to get 15. So this is going to be x and x. If this is a plus, I know these are the same. They're both plus, they're both minus. What do you think they're going to be? Both minus. Good. All right. And then we're going to look in the 36 box on our factor chart. And we want to find numbers that are going to add to give you 15. What do y'all think? 12 and 3, or 3 and 12, however you want to do it. All right. So that takes us to step 3, factor like normal. Step 4 is the divide part. So step 4, we're going to transfer the number back out of the constant term by dividing by it. All right, so over on the side, I'm going to do that. I'm just going to write divide. So what we'll do is divide both of those constants by 2. Right? And then step 5 says to reduce all fractions. Now this is where you might want to use your calculator to reduce the fractions. It's up to you. The calculator reduces fractions so wonderfully. But you can also do it in your head. So if you're not sure if 3 over 2 reduces, I hope you know that. Hi. What you can do is do alpha y equals, choose number 1, and then just put 3 over 2. And if it gives you 3 over 2 again, it doesn't reduce. All right, then we can do same thing for the other one. I grabbed a different one. All right, so then we have 12 over 2, which reduces just to 6. All right, and then the last step is the bottoms up step. And on the bottoms up step, anything that's still on the bottom is going to come up. And when it does, it comes up right in front of the X. And unless we made a mistake somewhere, which is possible, there's lots of little steps here, this should be how you factor it. Now, how can we know if this is right? You just multiply it back out. So I'm going to do that for this one. I'm going to multiply it back out. I'm going to distribute the 2x. And then I'm going to distribute the -3. And then I'm going to combine my like terms. And that's it. It matches with what I wanted, so I factored it correctly. Now, if your Algebra 1 teacher probably didn't teach you this method, you probably just kind of figured it out, like what multiplies to give you 2x squared. And then when you do that and that, you get the 15. And we can still do it that way. But I think this way is going to help you consistently get the right answer each time. All right, now the bad thing about bottoms up is sometimes when you multiply, you get really big numbers. Numbers that aren't going to be on this factors pairs chart. And we're going to do some of those, but this one, I'm going to change the problem because I don't want to do one of those yet. So on 14, let's change it to 5p squared plus 21p minus 20. So step one when you're factoring is always to factor out a common factor if there is one. Is there a common factor here? There isn't. It has to be common with all of the numbers, and so there's not one. All right, so then there's not a common factor, and there's a number in front of the p squared. So we're going to do the slide, divide, bottoms up. So we'll start with slide, where we're going to slide the 5 over and multiply it by the -20, and that's going to give you -100. All right, so it's slid over, so it's not in front of the p anymore, the p squared. All right, then we're going to factor like normal. We're going to multiply to get 100 and add to get 21. And what do we know about our signs if we multiply and get a negative? Different. One's a plus, one's a minus. So when they're different, you're technically going to subtract to get 21. All right, so if we're looking at 100, the very last one, and signs are different, so we want to subtract to get 21. What do you guys think? 4 and 25. Now we want to get positive 21, so which one of those needs to be positive? 25. If we want to get positive, the bigger one needs to be positive. If we want to get negative, the bigger one needs to be negative. Okay?
Yeah, I did it.
Okay, you just said the wrong thing. It's fine. All right, then we're going to divide. So we're going to divide by what we slid by, which is a 5. Then we're going to reduce all fractions. And then we're going to do bottoms up. So the 5 was on the bottom. It needs to bump over in front of the P. All right. And then if we multiplied that out, I don't want to because I want you guys to have a little bit of time to work in class, but it would give us that original problem. Yes, ma'am. I have some paper towels over there. I don't have any tissues. All right, let's look over at number 15. It's another one we're going to change. All right, we're going to change it to 3h squared minus 14h minus 24. All right, do we have a common factor on this one? 3, 14, and 24? No. So we do have a number in front of h squared. So we're going to do the slide divide bottoms up. So for slide, we're going to multiply that 3 by negative 24, and we are going to get negative 72. So then we just rewrite the problem with the 3 not there anymore, and 24 has been transformed into negative 72. All right, then we're just going to factor like normal. We're going to multiply and get a negative. Every time you multiply and get a negative, that's from multiplying a positive times a negative. So we have 1 plus and 1 minus. All right, and we're going to look at 72. Lots of things multiply to give you 72. So we're looking for 14 when we subtract, since the signs are different. What do y'all think? 4 and 18, good. All right, now we want to get negative 14. So the bigger one, it needs to be the negative one. So positive 4, negative 18. All right, so now we're ready to divide. Yes, ma'am? Thank you. I gotcha. Thank you. All right, now when we divide, we're going to divide by 3. Reduce all fractions. And then bottoms up. All right, now I know we have a lot more. Yeah, we have a lot more examples here available to do. I'm not going to do them all, but I do want to do one of the ones that doesn't turn out so perfectly. So we're going to do number 17 together. All right, so there is no common factor, and there is a number in front of y squared. So we're going to slide that 6 over with the 21. And that's going to give us negative 126. Whoops. All right. And then I'm going to multiply to get a negative. So I know I have a positive and a negative. Now, if you look at your factor pairs, they don't go to 126. So this is where you're going to just kind of have to figure it out with your calculator. So we're going to take 126 and we're going to just start dividing by numbers to see what goes evenly into 126. So if you're just going to guess something that goes into 126, what would you guess? To check. You don't have to know.
62.
60? Okay, 16 doesn't work. 2 does. But we need to be able to subtract those two numbers and get 5. So it's not going to be that one, but that's okay.
Wait, you have to subtract 6 and 32 to get 5?
Yes. So what else?
Can't you just subtract? Like,
We're trying to figure out what divides evenly into 126 to see if we can find those pairs.
6.
6. Okay. So we subtract those. So we're getting closer, but it's not quite 5 yet. It's okay. Just keep trying. All right. No. We're getting real close. 9. All right. So when I do 9, when I subtract those, is it 5? So we're going to use 9 and 14. So it definitely gets a lot more tedious if you can't use your factors pairs chart, but it's okay. There's only so many numbers you can try until you find what works. So it's going to be, whoa, sorry. All right, it's going to be 9 and 14. We want to get -5, so we're going to make the 9 positive and the 14 negative. All right, and then we're going to need to do the divide step, where we're going to divide those by 6. Right? And then if you're not good at dividing or at simplifying fractions, it's okay. Your calculator is great at it. All right, so 9 over 6 is going to reduce to 3 over 2. And then 14 over 6 is going to reduce to 7 over 3.
So you do bottoms up on both of them?
Yes. This is the first one we've had to do that. So we are going to have to do bottoms up on both of them. So we get 2y plus 3 and 3y minus 7. All right, we are going to do one more together. And it's going to be number 20. Does number 20 have a greatest common factor? Yes, and it is 8. So if all your numbers are even, you definitely have a greatest common factor. But this one, the greatest, is 8. So we're going to divide 3 by 8, and then it's going to make this problem pretty awesome, actually. So on a situation like this, do I need to do divide slide bottoms up? No, we're just going to do regular factoring. The 8's going to hang out on the front. It's going to be y, and plus, and then multiply to get 12 and add to get 7. It's just going to be 3 and 4, right? So when you guys are doing your assignment, I think there's 8 problems. I think 3 of them are like this one, where you don't have to do the new method. You just do it like we've been doing for the last few days.